Calculus kids, this is Dr. Callahan. Happy Monday. How are you guys doing? So I have a half day today, so make sure you guys watch the video in its fullest and have your guided notes, but I will be back for the afternoon for periods 4, 5, and 6. But I hope you guys have access to your MS team and are able to have access to this warm-up log. Go ahead and answer the following 3 questions. Keep in mind your warm-up log is due on week 9 Friday. This is week 8 Monday, so we have about 9 short school days before this is due. Let's go ahead and create the assignment for today so that way you guys actually can access it. And just keep an eye, anytime that I'm not there in person and you have a sub, just please go onto MS Team, whether it's on your cell phone or on your laptop. If you do need an iPad, I do have iPads on the left side of my desk. You're more than welcome to grab it. Your sub will also know that you are allowed to grab it as well. All right, so let's go ahead and take a look at our focus today. The last few days we talked about derivatives and integrals of trig inverse functions. Today I am going to talk about kind of like I guess it's going to be a review of the trig inverse and whatnot. So just more examples for you guys to practice with before we move on. And your assignment is due today by 3 p.m. So make sure you guys upload that. And then I'm just going to go ahead and sign. All right, let's go and take a look at the 3 examples that you guys have. Here are the first 2. They're from your textbook directly. These are the trig inverse integral rules. First thing you want to do is you want to notice, like, well, which one can I go ahead and make it so that it is matching to one of the integral rules. And then from there, make sure everything is in terms of du before you integrate it. And then essentially just matching everything up. So this is the answer for the first one. Here's the answer for the second one. There's not really anything that is super difficult. Fairly straightforward for the most part. And take a look at the last one right here. So with this one, notice how the numerator has a bigger power, and in which case you can actually go ahead and use either, well, you could just use long division. You could use synthetic division or long division. I personally just like long division because it's more straightforward, whereas synthetic division, backing out to the 2 honors, there are little things to do, like changing the opposite signs and then this and that, and long division just makes sense to me. So here you have x to the 4th, 0x cubed, 0x squared, 0x minus 1. Down the bottom, everything needs to be in the format where it's from the biggest to the smallest exponent. So if it's missing, you just put a 0x. So then from there, you just go ahead and make sure that your first term is the same. So that way you can cancel it. And your goal is to get smaller and smaller until you eliminate all of them. So your answer here in this case is the x squared minus 1 plus, don't forget your remainder divided by your divisor. So x squared minus 1, if you integrate this, it's fairly simple. You just add the 1, which divided by 3. 1 through x cubed minus 1 is just a minus x, and this is your answer. All right, so today, let's go ahead and take a look at what we're going to be talking about. Here is the breakdown. I'm going to go over 4 different practice problems with you guys. It's not in your guided notes, so I will recommend that you go ahead and just write it on a separate piece of paper, the ones we're going to go over in class today. And let's go ahead and take a look at your guided notes. So for your guided notes, after I go over the 4 examples, I want you guys to go ahead and pick some of these questions right over here. Try to see if you're able to do this on your own. If you're struggling, having difficulty, then go ahead and type in this tiny URL and check your answers with mine. And after that, here is a little bit more of kind of like a review. And if you would like to check the answers, your work should be right here. All right, so with that said, let's go ahead and get started. We're going to go ahead and go over 4 different practice problems. I'm going to show you guys the problem, and you can go ahead and pause the video and try it on your own. And then afterwards, I will go over the answers with you guys. All right, so here's your very first one. On the very bottom, I have the integral rules for you guys just to help you guys out. So pause the video, give that a try, see if you are able to get to the right answer. I do have some hints on the side that you might find helpful. Okay, so let's take a look at the first one right here. And looking at this, figure out which equation you are interested in using so you can go ahead and match it. I can see that this one is probably going to be very close to this one right here. So if I could go ahead and rewrite this, I'll have the integral of dx. I can go ahead and rewrite square root of 2 with a square root with a square plus 3x squared. And then you want to go ahead and do a u sub so that way you can change the dx here because I need to have this in terms of u's to do this. So we're going to say let u be 3x. du is just going to be 3 dx. And then dx equals du over 3. So once I have that, let's go ahead and rewrite it. I have a 1/3 on the outside. Change the dx with the du. And then I have a square root 2 squared plus 3x is going to be a u squared. Okay, so now that I have everything in terms of u, I can go ahead and match the a's. Now I know my a is going to be square root of 2, and then my u, in this case, is just going to be 3x. All right, everything is matched perfectly. Let's go ahead and change what the equation is going to be equal to. So that's going to be equal to 1 over a, so that's 1 over square root of 2. Arctangent u, which is 3x, over a square root of 2 plus c. And if you would like to go ahead and rewrite this so it looks a little bit better, you are welcome to do that. If you don't want to have a, well, actually, I guess you can't really do it. So let's just do it this way. 1 over 3 square root 2 arc tangent 3x over square root 2 plus c. And that is your answer for the first one. Two, let's take a look at this one. Go ahead and pause the video, give it a try on your own on a separate piece of paper. Don't forget the du and do not use arc sign is my hint. All right, let's go ahead and take a look at what we have here. So looking at this, I want to go ahead and see which equation it's closest to. It's probably going to be initially I want to say arc sign, but eventually going to see that one's not going to work and you're going to have to use this one. So for now, I'm just gonna let you guys know that in advance. But if you look in the denominator, you want to have an a square and a u square, obviously. So let's just go ahead and rewrite this. So I have a square root, and inside the square root, I can go ahead and write my x squared. So that's my first one, minus 1 squared. So remember, you want to go ahead and make everything in terms of u. So let's go ahead and say let u be, and the only one that I can think of it's going to be is e to the x. So then du is e to the x dx, then dx equals du over e to the x. Okay, but then if you think about it, isn't e to the x just u? So it's dx is equal to du over u. Now let's go ahead and rewrite this. I'm going to replace my dx with a du over u, square root, e to the x, remember e to the x is u, squared, minus 1 squared. So now notice you can't use the arc sine one because you need to have a u here, and instead you have to use the arc secant, okay? But everything is in terms of u, and I can see that my u is going to be e to the x, which means my a has to be 1. So then let's just go ahead and fill out the rest of this equation, which is 1 over a arc secant u over a plus c. So 1 over a is 1 over 1 arc secant, absolute value of u, which is e to the x, over a plus c. So my answer is just going to be arc secant e to the x plus c. And this is your answer. Okay, third one, let's go ahead and take a look at this one here. Okay, so as I'm looking at this one here, notice that the numerator's power is greater than the denominators, in which case you always use long division or synthetic division. So my strategy here is to use long division, separate the integrals, and then I'm going to use the arctangent formula once it gets to that point. So let's go ahead and do that then. I'm going to do my long division on the side. 3x squared plus, make sure you have your fillers in there because you need to make sure that if you don't have the x squared and the x, you put in 0. Your divisor is a denominator, which is x squared plus x plus 4. So x squared times what gives me 3x squared, it'll be a 3x. And make sure you distribute to all three terms here, which will give you 3x squared plus 0x squared plus 12x. Then let's go ahead and subtract it. This part will cancel. That will give me a 0x squared, and this will give me a negative 12x, bring down the negative 2. Okay, so then at this point, that's as far as you can go, because if you put anything else here, that number times x squared is going to be something x squared. I mean, you could put a 0, that's completely fine, but if you look at it, it's not going to change anything. You're still going to be left with a negative 12x minus 2 as your remainder. So then this is your answer right here, and we're just going to rewrite this as 3x plus, remember, it is always going to be your quotient, which is your answer, plus remainder over divisor. So your remainder is right here. This is your divisor. This is your quotient, okay? So r, which is going to be a negative 12x minus 2 over my divisor, which is x squared plus 4. And if you don't want to have the two negatives, you could go ahead and get rid of the negative by putting a negative here and a positive there. Okay, so we're just kind of factoring out the negative. And this entire thing is still in terms of dx. Well, let's go ahead and separate the fraction. Or actually not split, let's just go ahead and separate. There's no fraction to really split. If I go ahead and separate this, I have the integral of 3x minus, and we're going to split the fraction here. And the reason we want to do that is because even if you have a u substitution of x squared plus 4, du is made 2x plus 0. So 2x is not going to cancel with the 12x plus 2. It's just not going to happen. So in this situation, we're going to split the fraction on top. So I have a minus 12x over x squared plus 4. Don't forget the minus 2 over x squared plus 4. So the first one is actually pretty simple because the integral of this is just 1 plus 1, which is a 2, divided by 2. So your first part of the answer is just 3 over 2 x squared. So that's the first part. Now for your second part, let's see. Okay, so for your second part, what we can do is we do u substitution because I know that I can see that the derivative of x squared is a 2x. I can go ahead and make this a 2x by having a 2x and a 6, like that, because if you multiply it, that gives you 2x. So this is doable with just a u substitution. So I'm going to say u is going to be x squared plus 4. Du is 2x dx. And you know that your dx is equal to du over 2x. So let's rewrite this. And if I rewrite this, I will have a minus, move the 6 over, integral 2x over u. Change your dx to du over 2x. And you will see that you're able to cancel this part here. So you just have an integral of 1 over u. Well, what's the integral of 1 over u? Isn't that just L in u? What is u again? X squared plus 4 plus c. Okay, so there's your second part of your integration. Now your third part over here, I can see that this is going to be very similar to this one with an arctangent. So with this one, let's go ahead and say that let's go ahead and have u be x, a be 2 as I'm matching this. Let's see. If x is if u is x, then your du, which is going to be 1 dx, right? So if I rewrite this, I will have a minus 2 integral, change your dx to du over u is x, so this will be u squared plus 2 squared. And now that everything matches, I can go ahead and just take this, replace it with this equation right here. So I will have 1 over a, so plus 1 over a is 2, arc tangent u over a, which is x over 2 plus c. And wow, this one has 3 parts, but this is your answer right here. And no, it will not get harder than this. So this one's pretty difficult. Okay, so number 4. Go ahead and take a look at this one here. Pause the video and give this a try on your own. Okay, so let's go ahead and take a look at this one here. I'm just going to go ahead and show you guys the steps with the answers. So first thing we're going to do is we're going to rewrite this. We have a negative x squared plus 3x. Looking at this, the closest one I can see right now is probably the arc sine formula. But unfortunately, it's going to be kind of difficult to get an a square out of this. So we're going to ask ourselves, well, is it possible to go ahead and use maybe a completing the square? So with completing the square, there are certain conditions. You cannot have a negative x squared, so I'm going to factor out the negative 1. If I do that, this becomes an x squared, but the 3 becomes a negative x, 3x. Remember, plus space minus the same space, okay? And so looking at this here, then we're going to go ahead and take the middle number, which is 3, divided by 2, square root it, which is a 9/4. But because this is a negative on the outside, just keep in mind that this is actually a minus 9/4. And then you're going to plus 9/4 to balance it. And that's why you have a plus here. Even though this is a plus, the negative one makes it a negative. So just keep that in mind. So then what you can do is you can just go ahead and factor this. And because you created it, you know it's always going to be the middle number divided by 2, which is going to be x squared minus 3 divided by 2 squared. That is going to give you this part right here. Don't forget your negative 1. Don't forget your 9/4. So I'm going to put this back in there, but I'm going to rewrite it so that way I have my a, which is right here, and my u right there. Okay, so then I'm going to say that my u is x minus 3/2. My a is going to be square is right here. There we go. That looks better. U is going to be x minus 3/2. A squared equals 9/4. So a is a 3/2, which is exactly what you have here. And then if you look at for the du, derivative x is just 1 dx. That becomes a 0. So if you replace this, it gives you a du. So everything now is in terms of u. So if it's in terms of u, you can go ahead and just plug it in into this equation, which is going to be arc sine u, and your u is x minus 3/2 divided by a, which is 3/2, and you want to evaluate this from the upper bound to the lower bound. I don't like the way that this fraction is written, so I'm going to have to go ahead and rewrite it a little bit, or you can just, I guess you could just leave it here if you want. So if I plug this part in, I have 9/4 minus 3/2 divided by 3/2. So 9/4 minus 3/2 over 3/2. Common denominator means that this is going to become a 4, this is going to become a 6. 9 minus 6 is 3/4 times 2/3. That cancels 1/2. And that's where you get the 1/2 right here. Okay. Then when you go ahead and plug in the 3/2, you have a 3/2 minus a 3/2 over 3/2. That becomes a 0. Anything with a 0 on top is just going to give you a 0. Arc sine 0. That's where it comes from. What is arc sine of 1/2? Pi/6. Arc sine of 0 is just 0. So your answer here is just pi/6. And that is your area underneath this integral. All right, you guys, at this point, I would like you to go ahead and practice with this page here. And then when you're done, go on to the next one. And this should conclude your stuff for Monday. As always, stay safe and healthy and be kind to one another. Take care.